I enjoyed creating the video that you're about to see and genuinely hope it makes your life better. But please remember, I cannot pay my mortgage with passion. I cannot pay my bills with passion. I do need cold hard cash, and as we all know, YouTube has become a very hostile place for earning money for content creators. So please think about joining Eli at thecomputerguy.com or failednormal.com to get other content that's not necessarily on YouTube and to help support these projects that I do. Hello again. As you know, I am Eli, and today we are going to be doing a class on A plus safety. Yeah, that's right. We're going to do a safety class because if you're watching this A plus track, you're probably a noob. And although it's shockingly hard to hurt yourself as an electronics technician, it is in fact possible. It is in fact possible to hurt yourself very badly. So we're going to talk about some of the safety things that you should keep in mind when you're going to be repairing PCs, laptops, any kind of electronics. Basically, whenever you deal with anything that has anything at all to do with electricity, you have to be safe. Again, electricity not only can kill you, but it can do little things like blow off body parts, wipe out about a week's worth of memory. We'll talk about that in one of the sections, and do all kinds of wacky things to you. So don't be too scared. Don't be too scared. Don't be like, if I try to replace my graphics card, I might die. It's not quite that bad. But if you do something stupid, it could be pretty bad. So that's what our class is going to be today. So the first thing that we're going to talk about is the types of clothing and the things that you should and should not wear if you're going to be doing computer or electronic repair. This is one of those simple, easy things, but if you get it wrong, it can go tragic. So one of the first things, if you're going to be dealing with electricity, you need to take your jewelry off. Remember, whenever you're dealing with electricity, if electricity jumps out a little gadget or device that you're dealing with, it will always take the shortest path to ground. So basically, it's always going to try to get to the ground. And so if you have jewelry on you, a lot of times the electricity will try to jump into that jewelry in order to get the hell out. It's trying to do the great escape down to get to the ground. That's just how electricity is. One of the things that I've heard about, I've never actually seen this in the real world, thank God, because I probably would have nightmares, is where people have things like rings on their finger, and the electricity will jump into the ring. It will then arc inside the ring before it figures out how to get to the ground. And you're sitting there, you're like, but Eli, how does it arc inside the ring if your finger is there? Yeah. Yeah, that's a question. That's a question. It can be very bad. It can be very. I've heard of people losing their fingers over that type of thing. Again, and a lot of the computer-based stuff, you shouldn't be dealing with electricity that has that much that high voltage and such. But it is just one of those things you should take off. So any kind of necklace, I would take off necklaces. I take off jewelry. If I'm going to be dealing with electronics, I go in bare, just so that you don't have to worry about it. This is one of those things. Because I know some people out there, they're going to be, I've worked on electronics all my life and nothing's happened to me. But then you run into the one person where something has happened, and yeah, it can just get bad quick. Beyond that, things like your clothing, really honestly, with most clothing, any kind of normal clothing you wear is going to be fine. I would say you don't want anything too loose. The main reason why you don't want anything too loose, not necessarily for the safety concern, but when you're dealing with parts and additionally when you're dealing with screws, if you have loose clothing on and you're moving over your desk, it's easy for your loose clothing to knock the screws onto the ground. And then you get to have the funnest puzzle in the world to try to put that crap back together. So any kind of clothing you're gonna wear, whether it's gonna be button-up shirts, whether it's gonna be t-shirts or jacket or whatever, just have it relatively tight to the body so it's just not hanging all over any place. Because even with clothing like this, even with a shirt like this, it's just very easy. You know, somebody says something and you turn around and it's just close enough to the desk that it just sends 20 screws flying. Then you're just going to have a bad day. Beyond that, you should think about in your kit possibly having things like safety glasses. Again, when you're going to be dealing with electronics, and especially like a lot of old and dirty computers and a lot of things, just having some safety glasses on every once in a while is good to keep crap out of the eyes. And some people like little masks, little respirators. The reason for this, again, having done computer repair in Baltimore, um, let's just say people aren't the cleanest people in the world. Let's just say, especially doing computer repair in Baltimore City, you find out different people have different standards of hygiene. And you crack open some of those computers, and to say it's disgusting is a complete understatement. So a lot of people, they'll pull out, that can of air, and if you're going to be cleaning out a computer, you're going to be cleaning out a laptop, you pull out a can of air and you spray it just to make sure you get all the gunk and crap out of there. Normally that's fine. Normally, don't worry about it. You open up some of these things, they literally look like basically vacuum cleaners. And you open it up, and there's just so much dirt and just nastiness in there. So for some people, I'm not one of those type of people. You might just want to have, again, just a little face mask. So you put it on, you hose off the computer, hopefully outside, and then you bring it back in, because you are going to need to do things like clean out the computer. And the crap that's in there, if you breathe it in, it's gonna go down your lungs. So these are some of the things to be thinking about with the type of clothing and the things that you wear. The big thing is take off your jewelry. I was an Army electronic repair technician. We dealt with higher powered stuff than you should be dealing with PCs. But electricity, when you're dealing with electricity can get nasty really quick. And simply having metal stuff on your body while you're interacting with electricity, just doesn't seem like a good idea. So that's some of the things with basically like what you should be wearing. So whenever you're dealing with electricity, you do need to handle electricity with caution. Electricity nowadays, people are so used to it, you don't even think about it anymore. And the problem with that is that electricity is very dangerous. It can kill you. It can do a lot of damage to you. It can send you to the hospital. But so many of our electronic devices now have been created to make them so safe to the average user that you just don't even think about it anymore. It's like, yeah, electricity is dangerous, but unless you're sticking a fork into a power outlet, nothing's going to happen to you. Well, remember, you are now going to be an electronics technician. You are now going to be an A-plus desktop support person who is going to crack the case on electronic devices and put your little hands in there and try to fix whatever's going on. So you are now no longer using these devices as an end user. You are using them as a technician. And basically, these devices are designed so they're not as safe for technicians to use because, again, you've got to go in there, you got to handle the wires, you got to handle the batteries, you got to be able to swap stuff out, and it's just once you start dealing with that things, it's just not as inherently safe. So whenever you're dealing with electricity, you do have to be careful. And I know a lot of people are like, oh yeah, no big deal. But again, one of my stories from the Army days, one of my buddies, oh, it was so funny, because he got held back in one of the training sessions. So when I went through electronics repair, we went through in specific classes, and as I recall, it was like every 3 weeks a new class started. So this guy was going along. He was like one class behind me. I was talking to him one day and found out that he was getting held back to the next class. And I was like, "Oh, why are you getting held back to the next class?" Because I thought he was doing fine. Well, he started talking about his little mishap with electricity. So when we were doing the troubleshooting in our classes, we had these troubleshooting devices, basically little things that you plug little probes into in order to be able to troubleshoot the electronic devices that we're dealing with. And to be clear, these little troubleshooting devices, basically they were the Army equivalent of play school devices, right? Yes, there was electricity running through them. Yeah, there were connectors or whatever, but they were really safe and they were really rugged, and it's a kind of device where unless you left it plugged in and then jumped into a pool with it, I'm not really sure how you could hurt yourself. Like genuinely. This was a really safe device. And so basically we use this device, and you would plug in different cables from the device to the electronic thing that we were trying to repair. You would get the readings, and then based on the flow chart, you would plug in different stuff. Really, again, like play school simple. So I was talking to him. I was like, how did you fail that training? If you got it as far as that was in the program, how the hell did you fail that training? It was a paint by number thing. Well, he said, yeah, he wasn't really sure what happened. I was like, what do you mean? He said, well, I was sitting there, right? I was sitting at my work because they had, I think there were about 20 stations where we were. And so you'd sit at your workbench and you do, you practice and do all the testing while you're learning. And he said, all I remember is I was at the workbench and I remember plugging something in. And I was like, okay. And he's like, yeah, after that, I'm not sure what happened. The other people in the class said that there was a bright light. And then when they looked over, he was sitting there, or he was actually standing, like away from the desk, kind of walking in circles, going, na 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 na, and na 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 na, and na 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 na, and na 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 na. And whenever that L processed through his brain, and he came back to reality, he had lost a week's memory. Like, no joke. No joke. No joke. Like, a week's memory was just, he was like, yeah, I don't remember last week, to be honest with you. It's just all gone. It's all gone. And so in case anybody was like snarky and talking about it, there was no benefit to being held back in this program. It was a long, tedious, horrible program. You just wanted to get out as quickly as possible. And yeah, nobody knows what happened to him. He apparently did something really stupid. Apparently he did something really stupid. The good part was nobody saw it and he forgot what he did. So, yeah. But that's the thing. So when you're dealing with electricity, you got to be careful because really bad things can happen. Again, like I say, when you're dealing with like laptops, when you're dealing with power supplies, because a lot of stuff with computers, you're dealing with hard drives and optical drives and that kind of stuff, and that can't really hurt you. But there are when you're dealing with power supplies can do a lot of damage to you. Old CRT screens can do a lot of damage to you. Power inverters for LCD screens on laptops, they can do damage to you. So you got to be careful. It's kind of one of those things. Like 95% of the computer, you could probably like lick your finger and shove your finger in and you'd be fine. It's that 5% of the computer that So be very careful. Whenever you're going to be dealing with a computer, whenever you're going to be dealing with whether it's a desktop computer or a laptop computer, one of the things that you want to do is you want to discharge all of the electricity. So a lot of people don't realize there's a lot of different electronic components in a computer, obviously. You've got resistors, you've got transistors, that type of thing. One of the things you have in computers are something called capacitors. And so what capacitors do is they store electricity, and they store electricity in order to keep the electricity flow steady for all the little devices within the computer. And so the problem is they store electricity, and if you touch a capacitor, when you shouldn't touch a capacitor, it will release all the electricity it has inside it. And that quick, right? So you want to try to discharge all the electricity. One of the ways that you can do that is if you're dealing with a desktop computer or laptop computer, you unplug it from the wall. So you make sure it's completely unplugged. You then pull out the battery if there's a battery there, and then you hit the power button. And if you want to see the visual example of the electricity stored in the computer, a lot of times when you unplug it from the computer from the wall, you pull out the battery, and you hit the power button, you'll still see the cooling fans. They'll spin up for about half a second, and all of that electricity is now being released. Again, that doesn't make it completely safe. Do not sue me. It does not make it completely safe, but it makes it a hell of a lot safer. Also, that's one of the things with the electricity, why you want to discharge all of the electricity, is not only can the electricity hurt you, but it can also hurt the other components in the computer. So you've got circuits in the computer. So basically the electricity is supposed to go from this resistor to this transistor, up to this capacitor, over to here, down to here, blah, blah, blah. And that's all set up so that no damage will occur. Everything will be done as it's supposed to be. Well, if there's still electricity in the circuit and you do something stupid, like let's say you drop a screw or you drop a screwdriver into the computer and it shorts the circuit. So basically electricity can go from one point in the circuit to the next point in the circuit. The electricity flow may be too high for the components further on in the circuit, and then you'll actually damage those components. So that's one of the things you have to be thinking about too, not just the damage to yourself, but also the damage to the computer. Now, when you are dealing with computers, there are a couple of things you just should not do unless your electronics, You know what the hell you're doing with electronics. One of those is don't touch the power supply. Do not repair power. You know how you repair a power supply? Newegg.com power supply. That's how you repair a power supply. Again, power supplies. Power supplies take AC, alternating current. They turn it into DC, direct current. There's a whole bunch of capacitors in there that can hurt you very, 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 very badly if you do not know what the hell that you're doing. Especially now with the cost of power supplies. Again, pull the old power supply out, throw it in the trash, put the new power supply in, away you go. Now, I do know people will be like, oh, but people repair power supplies. Yes. If you know what the hell that you're doing and you're qualified to do it, by all means, repair a power supply. That's one thing where it can get people into a little bit of trouble, is because, when a power supply, it's a device that has a lot of different electronics in there. So a lot of times when the power supply is bad, instead of wanting to spend $50 on a power supply, you think, oh, it's only a 25-cent capacitor. And so that's where it gets people into trouble. If you don't know what you're doing, you open it up, you short something that you shouldn't short, and so just generally stay away from the power supplies. Also with CRT screens, again, you shouldn't be dealing with CRT screens at this point, but if they're around, again, they've got a lot of capacitors in there too. Generally stay away from the CRT screens. So this is just something to be thinking about with the electricity and these devices. Electricity can be very dangerous. Again, most of these PCs nowadays, it's not a huge deal. It's not like the old days. Oh, the old days used to be miserable. Like parts are keyed now. And so what keying means is that they can only plug in one way. So like with power supplies, so you've got the connector on the motherboard and you've got the connector from the power supply, and it only goes one way into the motherboard. Right? That's a beautiful thing. Little inventions that you don't realize did not always exist. Thankfully, I got into computer repair after this point in time, but I talked with buddies of mine where those little power connectors were not keyed in the past. So you literally could plug in the power supply the wrong way, and then all of a sudden you're pumping a hell of a lot of electricity into the wrong way into the motherboard, and hilarity ensues. I guess if you have the right sense of humor, as they say. So just be very, very careful with electricity. It can cause you harm. It can do some real damage to you. Stay the hell away from capacitors unless you know what the hell that you're doing. When you're gonna get into a computer, make sure you pull the power plug, you pull the battery, you push the power button to make sure everything is discharged, and then go from there. And just be careful. Treat all the stuff with respect. That's the best thing that can be said. Now, the first thing every A-plus technician wants to go out there and buy to prove that they're a real technician is their ESD wrist strap. Right? Real geeks use ESD wrist straps. Is not really the case. So when you're dealing with electronics, one of the things that you're going to hear is static kills. Beware of static electricity. And to be clear, this is in fact true, sort of. All right, so basically static electricity, right? Static electricity can build up on your body, and again, it's looking for the shortest place to ground. So if you touch something, you will feel a little static jolt. It might be a little painful. You might even see a little spark, and that is something that you have to worry about with electronics. So again, I was talking about electricity can destroy electronic components. Static electricity really and truly can destroy electronic components. Definitely can. Definitely, I will tell you, because I'm giving you a class that's supposedly for certification. I will tell you static can destroy electronic components. In the modern world, I can't tell you last time I wore a wrist strap. Probably the Army. In the Army, it's been a long time since I've been in the Army, right? That was probably the last time. And the thing that you have to realize is that static electricity, 100%, no argument, 100% can destroy electronic components. The thing is, back in the day, when I was doing electronic repair in the 90s, electronic components cost a hell of a lot more than they do today. So if you had like a 1% chance of doing damage to an electronic component, the cost of that component was so high that you didn't want to risk that 1% chance, right? Even something as low as that. The thing is, nowadays, as we go into the modern world, I mean, most components just aren't that expensive anymore, right? A lot of the components are going to be maybe a motherboard is $100, maybe. I mean, you get a graphics card, a 1080 or whatever the latest graphics card is, might cost you $800. Again, if you get something really fancy, maybe it costs you $2,000. But even those are actually relatively low prices. And so the reality is yes, static electricity can damage components. Again, it's been a long time since I've really worried about static electricity. One of the things that I would say, one of the ways that you can discharge a static electricity off of your body is if you're working with desktops, right? Open up the case of the desktop computer when you've got it opened up, since you're going to be working inside, and simply touch the bare metal inside that desktop computer, and that will discharge the static electricity that's in your body. And other than that, generally, I don't worry about it. But if you do want to worry about it, that's where you go and you can get an ESD wrist strap, and you can get a mat to work on. This is, I guess, probably what the certification people would tell you to use. Again, this is like a StarTech ESD anti-static wrist strap band with grounding wire. There is nothing really complicated to this. Basically, what it is this is a little this is a little stretchy wrist strap that goes around your wrist. And then on here, where this is, on the other side, what touches your wrist is actually just like a little metal button. And so that little metal button connects into this wire. That wire then connects into the alligator clip, and then the alligator clip connects. You connect it to something that's metal in order to discharge the static electricity. Basically, this is how it looks when you wear it, and it is just an amazing fashion statement if you want to buy one of these things. You'll also hear about anti-static mats. So again, if you're doing electronic repair, this is something that you may want to have. Essentially, again, you have the same thing. You have a mat, whatever size this mat is. That mat is connected again to a wire with an alligator clip. You connect that alligator clip to the ground, and then that removes the static from where you're working. Now, if you're gonna be worried about static, if you're worried at all about static, what I would say is get the mat. Right? If you're worried about it, again, this mat costs you, I don't know, $17, $20 for this particular mat. You get this mat, you put it on your work area, and then you forget that it even exists. The mat, I might say, I mean, you know, what the hell? It's $20. Get a mat. The wrist strap itself, though, again, I can't say I've ever used one outside the Army. And even in the Army, I basically only used it because I had to. And the devices that I was repairing, it's really expensive because the government was paying for it. You know what I'm saying? And so this is something just to think about, just to keep in mind. You know, if you're I don't know. Like if your house or whatever has, you walk around your house and you build up a lot of static electricity, you can feel it because you touch doorknobs or whatever and it goes off. That is something to keep in mind. And so touch a doorknob or touch something, try to discharge it before you work on the computer. But otherwise, this is one of those that it's made out to be a big deal for noobs, and then you actually start doing your real work and you kind of forget about it. Now, one of the things that I can tell you is probably one of the most dangerous parts of dealing with computers in the modern age is really freaking sharp metal. Oh, yeah. Electricity by and large, as long as you don't crack open a freaking power supply, you're probably going to be fine. Sharp metal is something that is hard to avoid. So what do I mean by this? Well, you know, you have all these, computer cases, you have all these devices, and they're obviously made out of pressed steel, right? So basically they take steel, they form it into whatever form, they cut off the bits, they throw some paint on it, they ship it off to you, right? Well, one of the problems that we run into is a lot of people decide to try to save money when they're building computers by saving money in ways that they think people will not notice. right? So a really good computer case. If you're going to go out and you're going to buy a good Cooler Master case or good Antec case or something like that, you're probably going to be starting at $100. It goes anywhere from like $100 to $300. And the reason is when you get a nice Antec case or a nice Cooler Master case, it's going to be nice, it's going to be heavy, it's going to be solidly built. And when you crack it open and you put components into it, you're generally not going to have to worry about getting stitches. Because all the metal, all that foreign metal, has been rolled over, has been sanded down so that you don't have, sharp, jagged, little knives in there. Well, the thing is, you go out, and a lot of people say, why the hell, Eli, why am I going to spend $100 on a case? I'm going to buy my case for $15. Well, you can, in fact, buy computer cases for $15. And honestly, as long as you wear your armor when you're going to work on it, it's fine, right? A computer case, and that's what a lot of people think. Why am I going to spend money on just simply the thing that houses the parts? Well, the problem is, and it is like when we were doing computer repair in Baltimore, you open up some of those cases, and it's just a whole mess of knives in there. Where essentially, like, what they do is when they form the parts, they just cut the part and then connect everything, rivet everything together, and ship it to you. So that means, the sharp edges haven't been sanded or haven't been bent over. You've got little jagged bits coming out in all kinds of weird places. And like when I say you can get stitches off of sharp metal in some of these really cheap cases, it is not a joke. So again, this is just one of those things, like, it's a heads up, something to think about. Again, especially why this comes with like cheap cases is when you buy a good quality case, whenever you open the case or whenever you're dealing with the components inside the case, it's going to be very easy to open the case. It's going to be very easy to deal with the components because everything is measured and everything fits how it's supposed to fit. Again, when you're buying a $15 or $20 case, things fit because you bang on it until it goes into position. Which again, that's fine, whatever. The problem that you run into is sometimes you have to use more force than you think, or you have to push on something and then it gives. And again, if you're pushing on something, it gives, and then you've got all kinds of sharp bits inside. Yeah, stitches ensue. So just be careful with sharp metal. Again, if it's between electricity and sharp metal, I don't know. Some days I think the sharp metal is going to be far more dangerous to you than the electricity will be. Now, the final thing to be talking about with safety with the A+, especially with a lot of noobs, is talking about cheap parts. Now, hold on a second. Yeah. I'm a Mac using, Whole Foods eating, hippie bastard, right? I know a lot of people are going to be like, Eli, we're not like you. We're not 41. We haven't been doing this for 20 years. We don't have money. We can't buy the high-end parts. We have to buy inexpensive parts. Here's the thing. Here's the deal. When you're repairing computers, when you're building computers, there's a difference between inexpensive components and cheap components. If necessary, buy inexpensive components. Don't buy the cheap components. Again, when you go and you're looking at these components, remember these are electronic devices. Electricity goes in, and hopefully the idea is that electricity is supposed to go out the proper ways. If devices are not built properly, all kinds of just nastiness can ensue. If you go out there and you buy cheap knockoff parts from wherever, I won't talk about any countries, from wherever, you can have things like fires. Again, that whole worried about electrocution and all that. If things aren't terminated correctly, if things aren't soldered properly, you can hurt yourself. So be very, 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 very careful with buying cheap components. That's where I would say you go to some place like Newegg. Again, go to Newegg and buy the lowest cost components Newegg has. Unless it's Rosewell. What, Rosewell? I don't trust that stuff. Personally, in my opinion, I would stay away from that. But anyway, most of the stuff there, like I say, it's got to be low cost. may not be the best in the world, but at least it'll have some decent safety standards. One of the problems that I've seen, especially back when I was a consultant, especially when I was still trying to figure out how to do business and how to do things with computer repair, is I ran into a lot of consultants, and what they would do is they would go to eBay or something like that, and they would buy the cheapest components, right, out of some particular country, and then try to foist that off on the clients. The problem is with components that are that low cost, many times they're dead on arrival, to be honest with you. They're dead on arrival. They don't really matter. A lot of times they just fail incredibly quickly. I had this big problem. The first partner I had when I learned how to do digital surveillance systems, he would buy, I didn't know what was going on at the time, and so he would buy these incredibly inexpensive cameras, and then the problem is, I was having to go back for warranty work like 3 and 4 times to a single job site. That just kills your profitability right there. But the other big problem, again, from a safety concern, is that you don't know how well these things are built. You have electricity going into them, and bad stuff can happen. A big thing that I'll say is something like power supplies. Again, if you want to buy a knockoff sound card or graphics card, I would not recommend it. But one of the things I would say, again, remember with the power supplies, that is where all the stuff with electricity happens in a computer. And so one of the big problems that I've seen is people will buy cheap power supplies. This really does happen. They will plug it in, and guess what? If that power supply isn't calibrated properly or isn't working properly, not only will that power supply kill itself, but the power supply will then kill the motherboard, will then kill the graphics card, might also kill the hard drive, all because it shoots way, way too much electricity out, and the devices on the other side can't handle it. So this is something to be thinking about, again, when you're going about buy components. I'm not telling you to go out and buy the latest and the greatest and best. I understand. Not everybody has the money. But don't buy the cheap knockoff crap. Buy name brand stuff from known vendors like Newegg or whatever, and go from there, because the really cheap equipment not only can cause you problems, but again, with things like fires, again, you think about it like, well, I didn't get electrocuted, so obviously it's safe. Well, if your client takes a computer home and it bursts into flames, well, you're fine. You're safe. They're kind of screwed, right? So again, inexpensive components, not cheap components. So that's all there is to this A+ class on safety. I know for the old timers, you're going to be sitting there shaking your head like, what is this stuff, Eli? Why are you doing these classes? Anybody should know. Well, again, anybody that's been doing this stuff for a little while should know this. But you get the 15, the 16, the noobs trying to do this. And yeah, it's always amusing to watch noobs. The best thing about noobs sometimes is they're so proud of themselves. They're like, Eli, I didn't waste my money on that $100 computer case, Eli. Eli, no, I'm too smart for that. I bought myself a $20 computer case. And oh yeah, you have fun with that $20 computer case. You go, girl. So these are just some of the things to be thinking about, because again, it's a lot of stuff that after a little while you don't even think about anymore. But when you're starting out, is something that you really should consider. Again, things like taking off jewelry. For me, this is just a normal part of life. Again, if I sit down and I'm going to be working on electronics, the ring comes off, it gets thrown where it gets thrown. I do my work. When I'm done, the ring goes on, so the wife sees it. She's always fine. Like, where's your ring? It's like, I was working on electronics. Don't worry, I'm still married to you, right? But you take the stuff off. Again, think about just having safety glasses or a mask if you're going to go out there, especially if you're going to be doing client work. Until you've seen it, you just don't realize how disgusting some of those computers can be. Again, the whole deal with electricity, basically the idea is you treat electricity with respect. Now, again, 95% of the stuff that you're going to be dealing with computers and laptops is 100% safe. Literally, you can lick your finger and you can shove your finger in there, and 95% of the time you'll be fine. 5% of the time you're going to the hospital. So again, it sounds like a joke. So, oh, hee, ha, ha, until, my buddy, right? You just sit there and it's not even it's not like when I think about the troubleshooting device that he was using, it's not like, oh, yeah, that would be really hard to hurt yourself. To this day, I just don't understand how the hell he hurt himself doing that. But he did. A week's worth of memory. gone. So you got to be really careful there. Again, we talked about the static. Again, I don't worry about static electricity a lot. If I'm dealing with a desktop computer or a server, I'll touch the inside of it just to make sure I discharge electricity. Otherwise, again, this was a big thing. And I've been an electronic technician since the time period it mattered. Back in the 90s, all this stuff was very expensive to deal with. Again, 12, 20 bucks in order to make sure you didn't destroy something made a lot of sense. Nowadays, I mean, you should see how some computers are used. You should see, I mean, like I had a buddy of mine who did computer refurbishing in Seattle, and he would store the computers out in Seattle, where it rains all the time. He would store the computers outside until it was time to refurbish them. Then he would bring them in, open them up, let them dry out for a day or two, and then do the repairs and then sell them, right? So again, is static electricity, but it's really not that big a deal. I wouldn't worry about it. If you're going to have a desk, if you're going to have a workstation, and you're going to do work, Chihuahua says hi. Then I mean, you may want to put a mat down. Again, having a mat on your desk, kind of protects your desk anyway. I guess you might as well get one, 20 bucks. But again, it's really not the big issue that people think it is. And then don't buy cheap parts. Again, I can't tell us enough. Fine, inexpensive parts, fine, whatever. But again, those cheap parts, I've seen people buy $20 power supplies and then fry every single component in their computer. Like, ha ha, Eli, I saved money on this power supply. You're like, wow, great. How much do you have left to replace every single component in your computer? Right? And again, when you're going down and doing repair work, this is something to be thinking about, like with those cheap parts, is you may be thinking about, and again, it's that whole luck thing, and it's that whole percentage thing. You repair your computer, maybe it's fine. You repair your family's computer, fine. You repair 5 or 10 computers with cheap parts, maybe you don't run into any issues. But again, you're going to be a professional, which means you're not going to be repairing 5 or 10 computers. You're going to be repairing hundreds or thousands of computers. And a 1% nasty failure rate, something like a fire or whatever, on thousands of computers is a lot of bad. A lot of bad right there. So again, go with the inexpensive stuff. Find the cheapest Antec power supply or the cheapest Cooler Master power supply. Go with a decent brand name from a decent vendor. Go for the low cost one, but don't go for that cheap, and you should be fine. And then again, like I say, the metal in the computers, not a joke. Again, that cheap stuff. Oh, that $20 case. Oh, I'm still surprised I have all my fingers from dealing with those cases in Baltimore. Those things, it's like razor blades. It's like riveting razor blades together. Bad stuff. So anyways, that was a class for A+ safety, third class in this A+ track. Hope you enjoy the class. I enjoy doing this, doing the video, as always. I look forward to see you at the next one. I hope this video has been useful for you, and you can use the information that I provided to go out and make the world a better place. But please remember that I cannot pay my mortgage with passion. It's true. I tried to do it the other week, and they were not amused. Here's a whole bunch of passion. Can I pay my mortgage with this? And they said no. So if you want to support what I do, whether it's the videos that I do for Eli the Computer Guy, the videos I do for Fail Normal, or even the in-person meetup we do every other week, please think about joining failnormal.com or elithecomputerguy.com. At the end of the day, all the passion in the world doesn't matter if you can't feed your family. And so by supporting me, by joining either of those two sites, you help pay for everything that I try to create and allows me to not have to worry about things like sponsors or whatever insanity is currently going on with YouTube.